Did you even watch any of the Oscar movies? Because like I don't think I watched a single Oscar movie. Oh, I guess Wicked is an Oscar movie, but I didn't see Wicked either. Oh, well, wait, like 3 more seconds. I mean, it depends on how long we want it to be. I mean, just review. Depends on how thorough you want to be. Do people have like the Oscars in the background, I guess? I don't even know how to spell parametric. All right, we're gonna start with parametric. Um, so it's a little bit weird because parametric fricks are very different than parametric multiple choice. Uh, what is the schedule for this week? I think I just like take the mock a bunch of times. I haven't decided when to take what and stuff. But we're doing parametric now, which is always fun. So parametric is so again on parametric polar. That's what we're doing today. Parametric is a little bit weird because I mean if you have time you might do part of the mock maybe. But parametric is weird because the fricks are very different than the multiple choice sometimes. We're going to start off with fricks because that's the most basic thing, I think. I'm going to write random stuff, but just keep in mind that as I do this, I'm not going to type things in calculators, so I'm just going to leave answers and stuff. I'm assuming you know how to do calculators. So let's get started. So when you have parametric, I thought I said you can use a calculator on the quiz. No, if you do a double derivative, you definitely don't have to. But that is one of the questions we're going to talk about. So I'm going to randomly create functions. Anytime you're taking a derivative, you don't really need to simplify it. And then given particle. So we'll run through this frick first, and then we'll get started. Particle is at 1,3. So these are the givens in a parametric frick. Again, these are always the givens in parametric frick. It's the easiest frick. Most of the time it's calculator. So keep in mind you're given two primes, one x prime, one y prime. You're given an initial time. Hopefully you know what this is for. This is for FTC when you want to find other points, as we're going to see. So we're just going to write random formulas down. And again, I'm not going to type in formulas, but let's get started. So first question is find the speed at t is equal to, maybe I'll type some things in a calculator, I'm not sure. Find the speed at t is equal to 4. So speed, and then we might as well do total distance right after this, because these are just two formulas of the particle from t is equal to 0 to t is equal to 4. So if you just know these formulas are good, and if you don't know the formulas, I mean, it's hard to come up with them. So the speed formula is just the derivatives, the Pythagorean theorem of the derivatives. And there is a difference between finding the speed at 4 versus find when the speed is 4. So here we're finding the speed at 4, so we're just going to plug in 4. And if it was find when the speed is 4, you would set it equal to 4. So in this case, we're going to write a big square root, and we're just going to plug in 4. Just be careful that sometimes the formulas have squaring in them, but you have to square the entire thing. And also to keep in mind that these are already the derivatives, so I'm not taking any derivatives for this question. So it's cosine of t squared plus the other one. Oh, I forgot to plug in 4, so I'm plugging in 4. That's the only thing you have to do in this question, if you know the formula. So this is the answer, right? It's not hard. You just plug in 4 into this formula. Okay, so find the total distance. So just like with particle motion, the integral of speed is total distance, and this is speed, so we're going to do the integral of this. Just keep in mind that when you're doing this, you're not going to plug in 4 into the formula. So this is what you would type in a calculator: 0 to 4 integral square root cosine of t squared plus e to the 2t plus 1 squared. I might type some questions in a calculator, but I don't think we have to do these in a calculator. Again, you just type in a calculator. Anybody have any questions on that? These two basic questions are just knowing formula. When is a 1/2 integral? That's polar area. That's very different than parametric. We will do that later. But that's not parametric at all. Okay, so again, speed is this formula, total distance is this formula. No 1/2 or anything, just the speed formula. Okay, so we're moving on. So hopefully you can still see the question up there. So let's find the position of the particle at t is equal to 1. So this question is always on there. Sometimes they'll ask just the x coordinate, sometimes they'll ask just the y coordinate. But in this case, we're going to find the x and the y. And how you do this is FTC. That's why you're given all this information here. And you do FTC twice, one for the x coordinate, one for the y coordinate. Let's set up FTC. So the position part, I'm going to call it x of t and y of t for the x coordinate and the y coordinate respectively. So I'm going to find x of 1. I have 4 numbers here. I'm going to ignore the 3 for now because that's the given y value. So it's always the given x value is getting added, so it's 1 is getting added. Then the given number, which sometimes is not 0, in this case it's 2. The given, or the t value is on the bottom here. The want t value is on the top, so this is how you set up FTC every single time. Dependent variable given plus given on the bottom, want on the top for the independent variable. Then you write the derivative. Again, you don't have to find the derivative because the derivative is already given. I'm going to quickly type this into a calculator. Give me 1 second. Just to have an answer. T equals 2 to t equals 1. So it doesn't really matter that the bottom number is smaller here. Yeah, given on the bottom, 1 on the top. You don't have to flip this as well because we're typing in a calculator. Supposedly this is 1.44306. So this question is asked every single time in FTC, so we're going to do it again. Y of 1. Same thing, but with the y coordinate instead. We have 3 numbers here. The given y value gets added, so it's 3. The given t value is on the bottom, 2, and the want t value is 1. So when you're doing FTC, and if you have to do both coordinates like we're doing in this question, just keep in mind that these the numbers on the integral or the limits on the integral will be the same, and it's like the given x value, the given y value, and the derivatives are different. So it's e to the 2t plus 1. So let's quickly do that. 3 plus e to the 2t plus 1, e to the 2t. And that is supposedly negative 21.604. So our final answer here is 1.443, because we're rounding the 3 places after the decimal, negative 21.604. Let me know if you have any questions on that. That's the big question. That's the 3-point question, or even the 4-point question on these bricks, so it's nice to get. D. For D, we're going to find the equation of the tangent line to the particle's curve, I think is how they usually phrase it, at t is equal to 1. Okay, so doing this, anytime you have a tangent line, you need a point and a slope. So just keep in mind, if this were the first question, and we hadn't done the previous question, we would have to find the point using FTC. So in this question, actually finding the point is harder. But we already did the work, so we're going to use our past selves, and we're just going to copy down this point. So this is the first point, and then now we need the derivative. And derivative, or the slope, is the derivative, and the derivative is dy dx. and that's just one derivative divided by the other derivative. So it's y prime over x prime. Just keep in mind that, again, these are already the derivatives, so I don't have to actually take a derivative. E to the 2t plus 1 over cosine of t squared. Now all I do is plug in t equals 1. So I do that, and I get e to the 2t plus 1. Trying to do that with a calculator real quick. Give me 1 second. T squared at t equals 1. And supposedly I get not a good number. Give me the decimal number, please. Uh, 15.526 or something. 527. So hopefully this makes sense. We have the point and we have the slope, so I like to write my answer in point slope form. Y minus the y coordinate, so it's going to be plus in this case, equals slope times, it depends on what your definition of useless is. So that's the parametric equation. That's the main questions. We didn't do acceleration because I think people can do acceleration. Just keep in mind that acceleration is the second derivative, but they already gave you the first derivative, so you would only have to take one derivative, one of this coordinate and one of this coordinate. And then what else did they not ask? Again, sometimes they would like say like when is the speed equal to 3? Sometimes they ask like where's the horizontal and vertical, like where's the tangent line horizontal, where's the tangent line vertical. That would be taking this derivative. So for example, if I want to see where it's vertical, I would set, so for vertical, good luck on anybody taking AB. This is a BC topic though. We have videos on AB videos, of course. But vertical would be setting the bottom to be 0, and you would just like use the solve button. So you would set this up. T squared equal to 0 comma t, and then you might need to do vertical bar stuff. So that's where the vertical tangent line. Yeah, doing acceleration is not hard. So acceleration would be like, so here's the derivatives again. So if it was like acceleration at t is equal to 3 or something, then you would find x double prime of 3 and y double prime of 3. Again, just be wary that this is already the derivatives. So I'm just going to do derivative at a point. So mischievous, you can't really see me take these derivatives, but I am taking one derivative. The hardest part of high school calculus is probably Taylor series, but that's a BC topic. The hardest part of AB calculus, I would probably say, is differential equations. Approximate. So again, I'm taking one derivative because I'm doing acceleration. And then double prime. Maybe just taking integrals is kind of hard too. T equals 3. And you get 2e to the 6th. That's a giant number. But it's 2e to the 6th. Sorry, we have a giant number. Euler's formula is just in BC. It's not in AB. So when do you set equal? You set it equal when you want to like find when the speed is equal to something. So if I wanted to find when the speed is equal to 4, I would set 4 equal to this equation. I would use the solve button. Hopefully that makes sense. So that's a lot of, that's parametric fricks. Speed, total distance, acceleration. What else did we do? And then the big ones are FTC, derivatives. So that's when you find the second derivative, But just keep in mind that when you're doing that question, that's only in the multiple choice. That's not on the fricks. I've never seen that question on the fricks, so just be wary of that. So I was about to do multiple choice questions, but again, parametrics is a little bit weird where the multiple choice and the fricks are quite different actually because the givens might be different. But if we're done with this this frick, we can move on to the parametric multiple choice, which we're going to do right now. So parametric multiple choice. When you're taking an integral of a fraction, you always want to use the power rule. Except ln, which is 1 over x. Okay, so parametric multiple choice. Why is it way different than the fricks? It's because the derivatives aren't usually given. It's usually the coordinate. So like, for example, like, let's say we have this, x of t is equal to t squared minus 9, y of t equals, give me 1 second, t minus 1 times t plus t minus 3. Okay. Let's do t squared plus t minus 10. And we want to find the direction or the primes of the particle at t is equal to, or sorry, when the particle is at 0, comma, can't do math real quick, 2. Okay, so we're starting this question. Again, the very main thing in these questions on multiple choice, not on fricks, is that t is not given. Like in the fricks, t is given, so that's the number you plug in every single time. So just keep in mind in these multiple choice questions, you have to plug in t. So, and I don't have a t. I'm sorry about that. But I don't have a t, so I need to find the t. So first off, I'm going to find the t at the beginning before I even take derivatives. Find the direction the particles go in or something like that. So what you do is just keep in mind these are both separate. So we set the x-coordinate to equal to 0. Then you set the y-coordinate equal to the number. Sorry, can't write. And then you try to solve these. And usually, again, you might have calculators. So you get t minus 3, t plus 3, and you get t is equal to negative 3 and 3. And then whenever you have a quadratic, you need to break everything to one side and you need to factor. Again, sometimes these are calculator questions, so you can just like type it in a calculator. But this one you get this, I think. Somebody check my math. And then you get the common time. So this is why this is harder than the fricks. And why it's harder than the fricks is because, again, I'm not given this time. So this is the number I care about, and this is the number that I'll plug in eventually. I will not plug in 0 and 2. That's the key step. So now that I have 3, all I have to do is plug in 3. So this is like t squared minus... So, no, sorry, we need to take derivatives. So let's take derivatives, 2t plus 1. And then, again, not plugging in 0 and 2, I'm plugging in 3. How do you know to find the common time? It's because you always want to find the time. 0, 2 are the x and the y, so you need to find the time. And what you do is you set the x-coordinate to equal to the x-coordinate, the y-coordinate equal to the y-coordinate. And you will get a common time, unless the question's really weird. So you're going to get 6 and 7 here. Most of the test is calculator except the last test, the last brick, which is polar. And then if these are both positive, this hopefully you know what this means. X prime being positive means it's moving right. Y prime being positive means it's moving up. And that's it. So again, this is a very typical parametric frick. Multiple choice where you're not given the time. Yeah, there's polar calculator and the polar non-calculator. I'm gonna move on because I think we're going a little slower than I wanted to because we need to get to polar, but we need to do a couple more parametric questions. The first one is the one that um, one of you alluded to earlier, which is the double derivative question, which again is a multiple choice question and not a Frick question. So it's like x of t is equal to t to the fourth plus 3 or something, y of t equals sine of t. We'll do something weird, and we're not going to simplify at all. Do you have a question, Stinkin? If I'm just going to keep going. Okay, so we're finding the second derivative here. So again, these questions are harder because we have to first find the first derivative. But that's just y prime over x prime. Y prime is cosine. X prime is 4t cubed. Then just remember that because of their chain rule, for the second derivative, you have to take the derivative of what we just found, and then you're going to randomly divide by dx dt. So it's going to be dy over dx, the derivative of this. Derivative of this, sorry, t, and then you have to randomly divide by dx dt. And notice that the t's will cancel. So take the derivative of this one and then randomly divide by dx dt. And then for this one, the first derivative didn't require low d high, but the second derivative will require low d high because it's a quotient. Sometimes this simplifies very nicely, so you will you can just like eyeball the derivative. But in this case, it's low d high. Low derivative of cosine is negative sine minus low d high minus high d low, which is 12t squared, all over low low. I mean, that's really late. And then randomly divide by dx dt, which is 4t cubed. And I don't need you to simplify, so this is the answer. On an AP exam, you might have to simplify. So again, this question is the most time consuming potentially. You have to take the derivatives, then you have to take the second derivative, and then you randomly divide by dx dt because of the chain rule. So when you take that second derivative, a lot of times you are doing quotient rule. But the derivatives are not too tricky. This would be, I mean, this part would be calculator, but you should take your derivatives by hand. Okay. So that's that. Not sure, not sure. Polar, one of them is calculator, one of them is non-calculator for part of it. It depends on how you guys do. Okay, so let's do this. So last question I wanted to do is the annoying question when we're taking integrals now. So acceleration will be these two things. And then we're given some time, so we're gonna given t is equal to 1, the velocity is 2 comma 4 or something, and then the position is, so s of 1 I guess, is 3 comma 5 or whatever. We're going to do this one last question. This is the most annoying question by far. Okay, so this question, because we're given acceleration, we have to take the integral. The question is find position, by the way, at any time. Okay, so to do so, we're going to have to take two integrals just to get, so we actually have to take four integrals in this question. We have to take two to get to velocity, because one for the x-coordinate, one for the y-coordinate, and then we have to do the same thing. And just be wary that as we do this, we're going to do FTC. So we're going to do plus C's, and we're going to plug in these points to find the plus C's. Yeah, good job, it's plus C's. These integrals should be pretty easy because, again, it's hard if they're not. The integral of 6t is 3t squared plus c, really c1 if you want. And then the integral of this is just 12t plus c. And then you plug in the point, like the given condition, to find the velocity. So we're going to cover up the position. We're just going to use this point right here. T is equal to 1, so we're going to plug in 1 here. And then we set it equal to the x-coordinate, or the velocity's x-coordinate, which is 2. And then we'll do the same thing with the y-coordinate later. Let's solve for the c, though. Looks like we're going to get -1, I think, if I can do math. Because this is 3, and this is 2, so it's -1. Then we're going to plug in, so some people would struggle with what numbers to plug in, but t goes into the t, and then you set it equal to either the x or the y. So this one we set equal to 2, and this one we're going to set equal to 4. We're doing parametric, so you missed the parametric, but it will record. So this is -1, by the way. And then, so now we have the velocity. It is 3t squared minus 1, 12t minus 8. Now, unfortunately, we have to do it again because we have to find position. So s of t, still with plus c's though. So integral of 3t squared is t cubed minus t plus c. 12t would be 6t squared, I think, minus 8t plus c. Now we're going to plug in t equals 1 into each of these, and we're going to set it equal to 3 for the x-coordinate and y for the y-coordinate of position. So let's do that. 3 is equal to 1 cubed minus 1 plus c. 1 minus 1 is 0, so c is 3 here. Then we are going to do the same thing for this one. So it's going to be 6 times 1 squared minus 8 times 1 plus c. And we're going to set this one equal to 5, because that's the given y-coordinate. 6 minus 8 is -2, so c is equal to 7. And we are done with this question. This is actually the most time-consuming question because you have to take 4 integrals. Q minus t, replace it with the c value that we found, and then same thing here. So that's the most annoying question, potentially. Yeah, we need to do the weird polar ones. But I want to do the more normal polar ones first. And then do the harder ones. Like there might be one hard polar question. But I was gonna do the more standard one first. So let me try to draw this picture. Please don't criticize the picture, but we're moving on to polar. Polar's harder. So the most typical one is this one right here. Just trying my best with this graph. Probably should have printed this out earlier. But this is from the homework if you haven't done the homework. This is a circle. And then we're trying to find, this is 1, I'm assuming, that's 5. So it looks like it crosses at 3, so it looks like it crosses at 3, crosses at 3, and then goes up to 5. Cool. And we're doing r is equal to 3, and r is equal to 3 plus 2 sine of theta. And then we are going to find the polar area. So we're finding the area in between here, if you don't see that. So polar area is the hardest part of polar in my opinion, because of one thing, which we're going to talk about. So polar. Okay. So when you're doing polar area, you want to first know which one is which. My picture is not the best, but this circle, or what looks like not a circle, but this circle is r equals 3 because r radius is equal to a number as a circle around the origin. And then the weird shape is the other thing. And then what you want to do is you want to, we want to find this area right here. That makes sense. Yeah, this is a homework question. We're finding this area. So remember, what you want to do is, because the outer fence or the outer border of the region is the circle for the top half, and then it's the weird shape for the bottom half, you always want to split this up into part of a circle, part of not a circle. It is true that x is equal to r cosine theta, y is equal to r sine theta. That will be relevant for like every other question in polar, but it's not relevant for the polar area question. So after this one question, it will be relevant. So again, if you can see, what we're trying to do is we're trying to find this area right here, this top semicircle, and then we're going to find this weird thing looking thing here. So like this shape, I think. Okay, so it's part of a circle, part of not a circle. For part of a circle, it's going to be pi r squared divided by something, and we want to determine how much of the circle is it. Well, hopefully you see that it's just a half circle or a semicircle, so it's just going to be divided by 2. And then you have to determine what the radius is. So it's pi times 3 squared over 2. Don't think about what this looks like too much. So it's 9 pi over 2. Then for this weird shape that you're all talking about right now, we have to do the formula. I don't know what it looks like, but we have to do the formula for this. So it's 1/2 integral of r squared. The only hard part about this is not any of this. Everybody should be getting this part right. 1/2 integral of r squared. The thing you might miss are the numbers. So those are the trickiest things. Just keep in mind that polar, I don't know if I emphasize this, but polar goes in a clockwise direction. So it always starts right here. This is theta equals 0. And then it goes this way. It goes first quadrant, second quadrant, third quadrant, fourth quadrant. It follows the quadrants. So when I'm graphing this, it'll go like, woo, woo. So like if I have a point here, it'll be like, here's my point and it's traveling like this. Or if I'm on the other one, it's like, here's my point and it's traveling like this. Traveling like this, traveling like this. So I need to know what this point is right here, and then this point is right here. And so what angles are those? But again, which point am I going to hit first? If I'm doing this portion right here, well, if I'm going to hit this one first because I'm on the particle and I'm traveling along the particle, and I hit this one first. So it's going to be pi on the bottom. And then what will be this angle? Well, this angle is 0, but it's the second time we hit this point, so this is going to be 2 pi. And that's the hard part. Finding the points of the integral are the hard parts of the question. And then you just type this in a calculator. 9 pi over 2 plus whatever this is. Just be wary that in these polar fricks, if you can kind of recognize the two numbers, first off, sometimes the numbers are just given, like pi over 3, 5 pi over 3, 4 pi over 3, something like that, where you have a harder portion of the circle, but the points are given. And then when you can identify the points, the bottom number will be smaller because they're like going clockwise, and the top number will be bigger. So that's why I knew it's pi to 2 pi. It's always, oh, is that counterclockwise? Yeah, that's counterclockwise. I don't know how clocks work, but we go counterclockwise. That was funny. But if you look at this unibow, again, don't look at what it looks like, but if you look like this is the picture we're trying to draw right here, like this graph right here. So we're starting off at this angle. So notice what portion of the graph is this? Well, it's in the bottom 2 quadrants. And what are the bottom 2 quadrants? Pi to 2 pi. So yeah, we are going counterclockwise, sorry. So it's this angle to this angle. A lot of times in these questions, it'll be quadrant based. So like if you have these 2 quadrants, the first quadrant, it will be 0 to pi over 2. If you have this quadrant, it'll be pi over 2 to pi. This quadrant, pi to 3 pi over 2. And this quadrant, 3 pi over 2 to 2 pi. But over on this question, we had the bottom 2 quadrants, so it's pi to 2 pi. Again, sometimes they'll just give you the angles. Or it's very obvious, it's only one picture, so it's obvious what angles to do. But if you're taking this test, try to break it up into part of a circle, part of not a circle. Yeah, you kind of look at what quadrant, but that's only if it like fulfills the quadrant. So sometimes it looks weirder, and sometimes it's like cut off by certain angles. where it won't be like that. Hopefully some of this makes sense. But try your best with polar. Again, the numbers are the hardest part, so try your best with that. But you definitely should have something 1/2 r squared as part of your answer. I'm going to move on to polar derivatives because that's the harder part. And then again, usually you don't have to do this integral if it was non-calculator. The hard part of non-calculator is the derivatives part. So we're going to do that. Polar derivatives. And we'll just take some derivatives here. Where's the question I want? Yeah, okay. So let's do some polar stuff. Yeah, hopefully we can get to loops. Okay. So the polar stuff is more important. So this is my function. I don't think the weird k thing will be on there. I think the loops will be on there. I don't think the k thing will be on there. It's like a very, I think they've only asked it one time. But loops they've asked like a couple of times, so it's more likely to be on there. Okay, so in these questions, just remember that if this is a given, there's a lot of derivatives. So I'm just going to review this really quickly. There's these derivatives. The theta derivatives are just taking derivatives. Just take derivatives. The r derivatives, you have to do chain rule because everything is in terms of theta. So it's dr, it's the easy derivatives times d theta dt, and usually it's given. D theta dt, and then dx d theta dt. And then finally, the derivative they asked a lot is dy dx. I didn't ask it on the quiz, I thought. Dy dx, it's the y derivative divided by the x derivative. Okay, so those are the derivatives you have to know. Theta derivatives are easy, t derivatives you have to multiply, dy dx is one derivative divided by the other derivative. So now we're doing cosine of 2 theta. So this is the given. And then we're going to find, sometimes they just ask like find the dx dy, but we're going to go straight to the hard question. We're going to do the equation of the tangent line at theta is equal to pi. This might get a little weird. I didn't check the numbers, but we're going to try this. So equation of the tangent line. Let me get some water real quick. So the important thing to remember, as Stinkin said, is x is equal to r cosine theta, y is equal to r sine theta. Once you move past the area questions, this is the only important thing. Then you immediately replace the r with what it is. So I'm going to pretend this is non-calculator just to practice some derivatives. Cosine. Okay, so x is equal to r cosine theta, y is equal to r sine theta. Now we're going to plug in pi to find the point. Cosine of 2 pi and cosine of sine of pi. The derivatives of the first column we're about to do, actually, that's the easiest derivatives. You just take derivatives. And then, like, for example, we're trying to find this derivative, dy dx, because that's the equation of the tangent line's derivative, the slope. So we had to find this derivative and divide it by this derivative eventually. But we're almost done with the point. 2 pi is the same thing as 0, so this is 1 times -1, so this is -1. Sine of pi is 0, so this is 1 times 0, which is 0. So my point's -1 comma 0. So notice how much harder this is than other questions because we had to do so much work just to get to the point. But now let's take the derivative. So I'm going to write the derivative here. So here's my x, if you can see. And again, we're practicing as if it's non-calculator. So this is always product rule. So it's negative sine of 2 theta times 2 because of the chain rule times cosine theta plus cosine of 2 theta times a derivative of cosine is still negative sine. So that's the derivative. Now we have to plug in pi, unfortunately. Again, this question might get a little bit weird, but we're going to roll with it. So sine of 2 pi and sine of pi are both 0, so this one ends up being just 0. Then I'm going to take the y derivative. So the question got weird because like it doesn't exist and stuff. But the y derivative is this. So now let's take the y derivative. Derivative of cosine is still a negative sine of 2 theta times 2 because of the chain rule. Derivative sine is cosine. Then the derivative of, where is this? Right here. We kept this the same. No. And then we multiply by, what did I do? Derivative, keep the same, plus keep the same derivative. Okay, so now we're going to plug in pi here. So notice that this has been a very long question. But this is all 0. And then so this will be cosine of 2 pi is the same thing as cosine of 0. So that's 1. Negative 1. So negative 1. So now we finally have all of our information. So remember, it's the y derivative divided by the x derivative, and this is the point. So it's going to be y minus the y point, which is 0. And then it's going to be the y derivative divided by the x derivative. So this doesn't exist, actually. And then x plus 1. So it doesn't exist. It's just the line y. It's the y-axis, actually. But just for mischievous, I am going to recap because it is a hard question. So what did we do here? We're trying to do equation of the tangent line. In order to do equation of the tangent line, you need a point and you also need a slope. To find the point, we use the fact that x is equal to r cosine theta and y is equal to r sine theta. Whenever you're using the fact that x is equal to r cosine theta and y is equal to r sine theta, what you want to do is, once you write that, you want to replace the r with what it is. So r was cosine of 2 theta from the very beginning of the question. So once we did that, and we know our trig values, we were able to find the point. But that's just the point. Now we have to find the derivative. And how do you find the derivative? Well, we have to find dy d theta over dx d theta. So to do so, we did product rule for each one because we didn't have a calculator of x is equal to r cosine theta, y is equal to r sine theta, and then we plugged in the number. Once we found the two numbers, that gave us our slope. It's the y derivative over the x derivative, which happens to be does not exist in this question. A very hard question, certainly, but sometimes we got to do hard stuff. Very time consuming. Sometimes you have a calculator, so it's easier. Like you can take the derivatives with the calculator. But on the non-calculator question on the exam for a frick, you should be expected to do this. And this is probably the bulk of the question. It's probably area, and then it's probably this sort of stuff. Oh, this is really similar to the one on the quiz, by the way. I didn't see that, but whatever. Okay. Hopefully that made sense. Okay, so somebody wants to do loops, so I can do some loops. Loops are very hard because of the weird thing. So I'm going to try to describe loops in terms of the context of the question that's in the homework. So let's do that. It's like the Taylor series test, 9 multiple choice, 3 fricks, one parametric calculator, one parametric calculator, one polar calculator, one non-polar calculator. So the loops again are not in the fricks. The loop is one multiple choice question, but I'm gonna try my best with this. Trying to pull up homework and stuff. The question we just did could appear on parametric, the multiple choice or the frigs. Okay, let's do this. So this is hard again, but basically we have this graph. And again, let's try to graph it together. There's ways to graph polar and with an Inspire or with another calculator, scientific calculator, but I kind of don't know how to do that. I learn every year and then I forget. It's kind of useful a little bit. So we have r is equal to 3 here, and we're going to draw r is equal to 3 cosine of 3 theta. But notice how I draw it as I draw it slowly. Again, as Owen pointed out, the loops, how the loops are, it goes counterclockwise. So it starts drawing like this. So the graph would already be on the page, but this is how it graphs. You start off right here, and then it goes through the origin, and then it goes like this, goes like this, goes like this, and then finishes like this. So this is, you would see this picture, but notice how I graphed it. You start off with this point and start going up, and you just like follow the curve logically. So like logically, in order to draw all this stuff, it would be like this. So in these questions, it's nice to know where the origin is. So in this case, the origin is right here, or what the angle is at the beginning. So angle 0 is this right here. And then you want to, again, because a graph like this, the first time it hits the origin, so this is angle 0, but the first time it hits the origin is what we care about, because if we can find this right here, this is a half petal, and we'll be able to multiply by 6, and we'll be able to find the 6 petals. So what I do is it will be drawn, and you just have to like, you won't be able to see it being drawn, but you try to find what angle 0 is. So I'm gonna plug in 0. When I plug in 0 here, I get 3. So I know that from angle 0, 3 will be one of the points. So I start off with angle 0, and then I imagine how it graphs in terms of hitting the first time it hits the origin. So I start off at 0, and notice the first time it hits the origin will be drawing 1/2 petal. So the formula would be 1/2 integral 0 to whenever this is equal to 0. So I need to find this number with a calculator potentially. Remember, the one thing you shouldn't miss is 1/2 integral r squared. And then I need to find this number. So you could use a calculator, find the first time this is equal to 0, or you can know some trig knowledge. So I divide by 3, and then which cosine is equal to 0, that's going to be pi over 2, right? So that means 3 theta is equal to pi over 2. So theta is equal to pi over 6. So this number should be pi over 6. I want to set it equal to 0 because when you set things equal to 0 because the radius is 0. And you set things equal to 0 when you pass through the origin. So I didn't do it for my first point because my first point's right here. But it draws like this. So the first time it hits the origin is when I want to set the radius equal to 0. And that was pi over 6. So it starts off at 0 and then it graphs and hits this number. And when it hits the origin, that's when the radius is equal to 0. So it must be pi over 6. That's not always the case. What I do is I plug in 0, and I want to see if 0 is through the origin. If 0 is through the origin, then that might be the first time as well, so then you want to find the second time that it hits it. But I like to find where the angle 0 is. Angle 0 is different than the origin if you don't know. But now I get pi over 6. Just keep in mind that this is only half a petal, so I have to multiply this by 6 if I wanted to find all the petals. And then if I wanted to find the other area, like this area right here, I would have to do a circle minus. So I'd have to do like pi r squared minus this number. If it doesn't start at 0, that means that the angle 0 is probably still the bottom number. But then like if you like draw it correctly, the first time it hits the origin is probably a full pedal as opposed to a half pedal. Because if it's a sine one, it starts like this and it goes like, how does it go? Doesn't it graph like this and like this and like this, for example, or like 8? So a sine one starts at the origin, goes like this. So the second time, so the first time it hits the origin is 0, and then the second time is whatever the second time is. But that one you'll have a full pedal as opposed to a half pedal. If that makes sense. So again, I mean, it's different between cosines and sines basically. So with these cosines one, the bottom number will always be 0. The question is, are you drawing a half pedal or are you drawing a full pedal? For cosines, the first time you hit the origin will be a half pedal, and then for sines, the first time you hit the origin after x equals 0 or theta equals 0, that'll be a full pedal. Yeah, set it equal to 0, but the question is, do you multiply by 6, which is the double the number of pedals, or do you multiply by 3, the number of pedals? And I think for cosine, I think this is right? For cosine, you're drawing half pedals, so you multiply by double the pedals. And then for sine, you set it multiplied by whatever the number of pedals is, because you're drawing full pedals. Yeah, I think that's right. And then use a calculator or use your trig knowledge to find this first number. But if it's a weirder question, if it's like a loop within itself, I think we did some of those. You always want to set r is equal to 0 at some point. That will be one of the numbers. The question is if that's two of the numbers, or do you need to find the first two, or do you need to multiply by 2, stuff like that. I am reviewing my pre-calculus knowledge from a long time ago. I think it is true that cosines, like 3 cosine of 3 theta draws 3 pedals, and I think the reverse is true for. So like cosine of number theta draws number pedals, but sine of number theta draws 2 times the pedals. But again, this is a very small question. Like, I don't really care about this question. Are we gonna do more polar questions? Like polar distance we didn't talk about, but distance is easy. Distance is one radius minus the other radius, and you might have to take a derivative. There is a way to determine which one is the out and the in. All you do is you plug in the angle you care about, and whichever one is farther out is the bigger number, and the smaller one is. Yeah. Let's listen to Jackie, and let's do one polar interpretation question, especially the drdt. So I'm gonna do that real quick. So like this question, for example, like if I have r is equal to 2 minus 4 sine of theta, and then I want to find this, we know this as well, and we want to find drdt at t is equal to pi over 6. Yeah, rate of change is rate of distance changing is not drdt. I mean, you have 2 of them, so I guess it is, but it's one derivative divided by the other derivative. Yeah, it's this question right here. So Owen, you have this question, and it will say like find it, and then it will say interpret. So for example, in this question, again, the theta derivatives are easier than the t derivatives, because you have to use the chain rule. So here, keep in mind we're not doing x or y, we're just doing r. So we don't have to write x is equal to r cosine theta or y equals r sine theta. So it's the theta derivative divided by this weird number. So really it's just the easy derivative times 6. But we do have to take the derivative. The derivative of 2 minus 4 sine is negative 4 cosine, I believe. And then we have to plug in pi over 6. Let me try to think about the unit circle real quick. 30 is the smaller. How do I still think about this every single time? It's going to be the longer sign, so I think it's root 3 over 2. And then things cancel. So you get negative 12 over root 3 as the answer. And then, so this is actually the most missed point probably, is interpreting this, because people confuse this. This is negative, so that means that the particle is moving closer to the origin. Most people know that the xdt being positive means right, the xdt being negative means left, the ydt being positive means up, the ydt being negative goes down. It's the r derivatives that people struggle with the most or can't remember the most. But drdt being negative means it's going closer to the origin. And I think we did a lot of parametric polar. Parametric, remember FDC, remember dy dx, speed formula, total distance formula, and then equation of tangent line. Polar, yeah, negative is closer, positive is away. Polar, remember 1/2 integral r squared. Try to break up weird shapes into circles and not a circle, and then use that formula 1/2 integral r squared. Try your best with the angles. Smaller number goes on the bottom. Everything else is x equals r cosine theta, y is equal to r sine theta, where to take derivatives, these derivatives, they're easy, maybe using product rule or something, but these derivatives you have to multiply, and then dy dx you have to have one over the other. Hopefully this was useful for you. It is not the easiest thing in the world. It is still VC. The only easy part of this test, the very easy part, in my opinion, is parametric with a calculator, Fricks. But everything else is not the easiest thing in the world. But it's not the hardest thing in the world. Like the derivatives are product rule, a lot of trick stuff. Polar is a little bit harder. Sometimes people think that the polar non-calculator is a little bit easier because if you're careful with like derivatives and stuff, you'll be fine. But does anybody have any other questions? Polar is hard, but again, 1/2 integral r squared, and then x equals r cosine theta, y is equal to r sine theta. Take some derivatives, and you should be fine for a lot of the points. Like, you might mess up a loop, for example, but other than that, it's not too bad. But I'm a little tired, so I'm going to go play some chess. Unit circle is not bad. Like, you should know, like, just no pi over 3, no pi over 6, and then no like 0 pi, pi over 2, and so on. The inner and the outer is very easy. You just plug in the number. So if you want to find if you have two numbers and the angle is like pi over 3, you plug in pi over 3 into both of the functions. So it'll be like r is equal to something and r is equal to something. And you'll plug in pi over 3 into each of them. And whichever one is bigger will be the outer one, and then the smaller one will be the inner, and you'll just do out minus n. Yeah, just memorize cosine of pi over 6 and like cosine of pi over 3. Like, just memorize them. Or just do unit circle stuff. Or draw triangles. But that's it. Hopefully that was useful. We just hit the hour mark, so I'm going to get going, and I will see some of you later. Thanks for joining.